Advanced Math Lesson 74, Kramer's Rule. This is one of my most, I really like this part of math, especially Kramer's Rule and determinants, because one, these are really, really important as far as coding and computer software. If you want a job in, software engineering, you have to understand matrices and how to use them. And then two, because it makes solving systems of linear equations so much easier. There's a little bit in the book about Kramer, who he was. I'm not going to focus on that right now. Maybe we'll talk about him in class. Actually, yeah, we should. I hope I do. We're going to do a quick review of matrices as far as what we learned so far, and then determinants of matrices. So if you remember, a matrice is a block of information represented in rows and columns. I'm going to create a 2x2 matrice right now. And then if we wanted to find the determinant, so this is a 2x2, read as 2 rows, 2 columns. And then the determinant is we start right here in this first position. We multiply this way. So we take 2 times 4, and then we're going to subtract the other multiplication, or 1 times 3. And that will give us a determinant for this matrix. So the determinant for this matrice is going to be 8 minus 3, which is 5. So this matrix has a determinant of 5. Now, we have to review determinants because we're going to use these in Kramer's Rule, because Kramer's Rule tells us some cool ways to solve systems of linear equations. Let's see here. Where is it? If you guys remember the equations that we've been solving, where we had ax plus by equals e, and then cx plus dy equals f, and that stuff, and we were saying, hey, what's the formula when we solve for y? We end up with the form for matrix determinants. In this equation, what we find out is that if we were to set this up into a matrix, x would equal the matrix of E over F. Why did I put a line there? Not a fraction. E over F and then B over D divided by the matrix of A, C, B, D. Right now, this is probably looking like alphabet soup. It's okay. It'll make sense later, I promise. So if we take the determinant of this matrix and then divide it by the determinant of this matrix, that will give us the value of x. Now, and then for y, similar thing. Y is going to be the determinant of AC over E F, and then ACBD. Right. So the thing you'll notice about these formulas for determinants as far as solving these linear equations is that the denominators are exactly the same. And if you look at the denominators are just the coefficients of x and the coefficients of y. So that's why this isn't that crazy. To get the denominator, all you have to do is just cover this, get the coefficients of x, coefficients of y. Those are going to be your denominator every time. Now, when it comes to solving for x and y, the numerators are what change. And you'll notice in x and y, they both have EF. EF being the whole numbers at the end. So in x, EF comes first, and y, EF comes second. Right? And that makes sense, because if you think about it, EF is taking the place of x in the equation, because we don't know x. And when we do coordinate pairs, they always go in the form of x comma y. So in the numerator, EF is going to take the place of x, and if you're solving for y, EF will take the place of y. So that leads the question, what is the other portion? Well, the other portion is the coefficients of y. And that's why I said this is going to make sense. So it's kind of like the xy coordinates, and then whatever you're solving for, you replace with the whole numbers. So the denominator is going to be the same every time, coefficients of x and y, the determinant of those 4 numbers, and then the numerator is going to change based on what number you're looking for. So if I'm looking for x, I take the coefficients of x and I replace them with E and F. If I'm looking for y, I take the coefficients of y on the right and I replace them with EF. Now, if you made it through all that and you're still with me, you're not totally lost yet, let's go ahead and apply this. So, where's my blue pen? There it is. Ha! So we'll take a system of linear equations like this. We have 3x plus 2y equals 5. And then we have 6x plus 4 y equals 10. Now let's say I want to solve for x. Now I know that the denominator's determinant is just going to be the same, the left side, not the whole number. So this determinant is going to be 3, 6, 2, and 4. And again, I'm only pulling the coefficients. I don't want the x or y unknowns. That'll mess up my answer. All right. Now for the numerator, since I'm looking for x, I'm not going to put the x terms. Instead of the x terms, I'm going to put 5 and 10. And then the y terms will be 2 and 4. So the solution for x is going to be the determinant of these two matrices divided by each other. So again, to determine the matrix 5, 10, 2, 4, I cross multiply. 5 times 10 is going to give me 20 minus 10 times 2, which is going to give me 20. So that's going to be 0. And then down here, I take 3 times 4, which gives me 12, and then 6 times 2, which gives me 12. So 12 minus 12 is going to equal 0. So my answer is 0. So x is going to equal 0 in this equation. And then the funny thing is, if the denominator is 0, then this equation is actually undefined. Man, that was a lame example. Why did I use that one? Either way, it still works. X would be equal to 0, and this method is this system of equations is kind of undefined. So we'll do it one more time. I'm going to use a different set of equations so I don't end up with 0 as the answer. And hopefully it'll make more and more sense. So remember, the denominator is always just going to be these 4 numbers, right? And then the numerator, if you're looking for y, it's like that. That's the numerator. If you're looking for x, then you cover x and take 5 and 10 and put it where x goes. So pretty much, if you want to solve for the numerator, you just cover those numbers and then take 5 and 10 or whatever whole numbers are on that side, and you plug them in over the x and y, and that becomes your determinant. Let's do another one. And I'll do this one for x and y. I'll make sure it has real answers. Here we go. We have 5x minus 3y is equal to 1 over 2x minus 7y is equal to negative 17. Okay, so x we'll put up here, y we'll put down here. So x and y are both going to have the same denominator. To get the denominator, I'm just going to cover up these numbers, and I have 5, negative 3, 2, negative 7. So 5, negative 3, 2, negative 7. That's going to be both the denominators. Now for the numerators, the numerator for x, I cover up x. Instead of putting the x numbers, I put 1 and 17 first. So negative 17. And then for the y numbers, I put negative 3, negative 7. Whoops. Keep wanting to write them as fractions. So that becomes the formula for x. Now for y, that determinant, I'm going to cover up the y terms, and I have 5, 2, 1, negative 17. So 5 and 2, and then 1 and negative 17. Eventually, I'll stop writing these as fractions. Hopefully by the time I teach this lesson, I won't. Now, all we have to do is figure out the determinants. The cool thing is the denominator determinants, they're going to be the same both times. So I really only have to solve it once. So 5 times negative 7 gives me negative 35. Negative 35 minus 2 times negative 3, or minus negative 6. That becomes a plus and a positive. So the denominator is going to become negative 29. All right, and that's going to be for both of these. So they're both going to have a denominator of negative 29. Now let's talk about the numerators. So this one is going to be 1 times negative 7. So I've got negative 7 minus negative 17 times negative 3. That's going to become a positive number. 3 times 10 is 30. 3 times 7, 21, 51. So 7 minus 51 is going to give me negative 58. So negative 58. Now negative 58 over negative 29, those actually reduce. The negatives will cancel, make it positive. And then 29 goes into 58 2 times. So x is equal to 2. So in our answer, we're going to have 2 comma whatever y is. So now let's do the determinant for y. 5 times negative 17, that's negative 50. 5 times 7 is 35, right? Yeah, 35. So negative 85. So I've got negative 85. And then 2 times 1 is 2. Negative 85 minus 2 gives me negative 87. Will those divide? Actually 9 times 3 equals 27. Maybe they will. Let's use a calculator. 87 divided by 29. 3 times. What do you know? Cool. So negatives cancel, and that becomes 3. So y equals 3, so we have the pair 2, comma 3 for our answer. And we were able to solve these two systems of linear equations using matrices, as opposed to substitution and elimination and all of that stuff that you've been struggling through since Algebra 1, Algebra 2, and even into this year. So matrices are cool. Cramer's rule is cool. If you want to get into computer science, learn your matrices. That's all there is for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.